Hello friends, welcome back to the problem session here. So we solved a few questions in the previous video. In this one we will take up slightly more challenging questions. So here it's actually the trigonometry is exactly the same. We will be using the exactly same formulae as in the previous ones, but here you'll have to just you'll have to put more or apply more of those formulae. It may be a bit tricky, so stay with me and I'll tell you where all which points to focus more on. So let's look at the first question. If sine of pi cos theta, it's not just theta or alpha or something else. The argument itself is pi cos theta. So if sine of pi cos theta is equal to cos of pi sin theta, find sin 2 theta. Okay, so let's start. Okay, let me write it down. Sine of pi cos theta equal to cos of pi sin theta. Now, as we are all aware of, cos of anything can be written as, in terms of complementary, the complementary formula, it can be written as sine of pi by 2, minus sin theta, okay, I'll just erase this part. Okay. Now, cos of x can be written as sine of pi by 2 minus x, right? But at the same time, cos of x is also equal to cos of minus x. So cos of minus x is also equal to cos of x, and hence is equal to sine of pi by 2 minus x. Hence, combining these two, we get cos of x is equal to sine of pi by 2 plus or minus x, right? So the only thing is you have to also remember that cos of x is also equal to cos of minus x. Hence, using this, we use this in the given equation. So sine of pi cos theta can be written as sine of pi by 2 plus or minus pi sin theta. Now these are just sine. The argument we can now easily match the argument. So we get pi cos theta is equal to pi by 2 plus or minus pi sin theta. Pi is a non-zero constant, cancels throughout, and we have cos theta is equal to 1 by 2 plus or minus sin theta. Fine. This is our equation. Let's take sin theta to the other side, and we have minus plus sin theta plus cos theta equal to half. Let's square both sides. Okay. And what do we have here? Minus or plus, when squared becomes positive, so it is sin square theta, then it is cos square theta. Now minus retains minus, so minus, plus retains plus, so plus 2 sin theta cos theta equal to 1 by 4. Sin square theta plus cos theta is always 1, so that is 1. Now note that 2 sin theta cos theta is nothing but sin 2 theta, and that is what is asked, isn't it? So we have now simple terms of sin 2 theta plus or minus sin 2 theta is equal to 1 minus 1 by 4, or that is 3 by 4. So sin 2 theta equal to plus or minus 3 by 4. Now the only very important part of this question, which otherwise is completely normal, is this part. Cos of minus x is also equal to cos x, because if we ignore that, we get only one value of sin 2 theta, the other value we will not get. So we have just keep in mind that cos of x is equal to cos of minus x. This is actually called an even function. So cos x is an even function. Sin x, however, on the other hand is an odd function. Sin of x minus x is equal to minus sin of x. So that is the thing we are supposed to keep in mind. and hence we just get sin 2 theta is equal to plus or minus 3/4. So let's go to the next question now. ABC is a triangle and tan a by 2, tan b by 2 and tan c by 2 are in HP. HP is nothing but harmonic progression. Then find the minimum value of cot b by 2. Now ABC is a triangle, or in other terms we can say ABC, a plus b plus c is pi. So any of the conditional identities conditional in this the condition being a plus b plus c is equal to pi, we are supposed to use them. So I'll directly write the key idea or the key identity we are supposed to remember. You can otherwise also find derive that very easily. That is cot a by 2, cot b by 2 and cot c by 2. These three always follow this, or always have this kind of relation. Cot a by 2 plus cot b by 2 plus cot c by 2 is equal to cot a by 2, cot b by 2, cot c by 2. Okay, if you remember, for ABC equal a plus b plus c equal to pi, we have the relation of tan as tan a plus tan b plus tan c is equal to tan a plus tan b, so tan a into tan b into tan c. So the sum being equal to the product. The same thing we have, but for half angles of the triangle. So this formula, if you remember, great. Otherwise, this can be derived pretty easily. Now we are supposed to use this, and how do we use this? We have the given as tan a by 2, tan b by 2, and tan c by 2 are as the terms of an HP. So this gives that the reciprocals, the HP is defined. HP are those numbers whose reciprocals are in AP. So now the reciprocals of these respective terms are their cotangents. So we get that cot a by 2, cot b by 2 and cot c by 2, they are in AP. Hence cot b by 2 can be written as cot a by 2 plus cot c by 2. But from this expression, from these two expressions, we get cot a by 2 and plus cot c by 2 is nothing but cot b by 2. So 3 cot b by 2 equal to cot a by 2, cot b by 2, cot c by 2. Now b, the maximum value of b, b cannot be 180 degrees, hence b by 2 cannot be 90 degrees. The maximum value of b is still less than 90 degrees. So cot b by 2 will never be equal to 0. Hence we can cancel this, and we have the relation cot a by 2, cot c by 2 is equal to 3. But putting it back in the now we apply the AMGM inequality. So we have by 3 is equal to now we have cot a by 2, cot b by 2 and cot the sum equal to the product. So this can be written as the product itself. Greater than equal to 3 times cot a by 2, cot b by 2, cot c by 2 power 1 by 3. Let's cancel this part, and so we have here power 2 by 3. Now we know that cot A by 2 and cot C by 2, the product is equal to 3. So 3 cot B by 2 power 2 by 3 is greater than equal to 3, right? So cot B by 2, let's square both the sides power 3 by 2. So we have 3 cot B by 2 by 3 into 3 by 2 is greater than equal to 3 power 3 by 2, which is nothing but 3 root 3. This is the power gets cancelled. We have 3 here. Hence we get that cot B by 2 is greater than equal to greater than equal to root 3. Hence this is the minimum value. And so this is the key idea here is knowing the relation that cot A by 2 plus cot B by 2 plus cot C by 2 is equal to cot A by 2 cot B by 2 into cot C by 2. So using this we get that the minimum value is root 3. Fine. Let's go to the next question. The next question is, if cos phi theta equal to A cos theta plus B cos cube theta plus C cos pi theta plus D. So what they're doing is they're expressing cos phi theta, a multiple angle, in terms of the basic angle theta, and obviously the sum of it's a polynomial in cos theta, and I'm supposed to find out the sum of the coefficients A, B, C, D. Fine. So let's start with the left hand side, and let's try expanding it. So cos phi theta. Now we'll be using obviously the sum formula, because there is no direct formula for phi theta. I mean there are formulas for 2 and 3. We don't even have any easy formula for or simple formula for 4 theta. So we'll directly go with 2 and 3. So this is nothing but cos 2 theta plus 3 theta. So expanded, this is cos 2 theta cos 3 theta minus, remember there is a minus sign here, sin 2 theta and sin 3 theta. Expand everything here, and cos 2 theta now is can be expressed in both. I mean there are 3 different forms, but take the one which has only cos theta, because you see the final expression has only cos theta. So this can be written as 2 cos square theta minus 1. The next is 4 cos cube theta minus 3 cos theta. Now sin 2 theta has only one expression, that is 2 sin theta into cos theta. The next one is 3 sin theta minus 4 sin cube theta. Alright. So this can be written as let's expand everything. This is 8 cos power pi theta minus 4 cos cube theta minus 6 cos cube theta plus 3 cos theta minus let's take sin theta common from here. So that is sin square theta. There is one sin theta here, and there is one sin theta here, and this sin cube theta. So there is another sin theta there. So I'll take everything common. That is sin square theta, and that can be written as 1 minus cos square theta. There is 1 cos theta, and there is 3 minus 4 sin square theta. So that sin square theta again write as 1 minus cos square theta. Fine. So let's expand everything again. 8 cos power 5 theta minus 4 cos cube. 4 and this is also cube. So this is 10. Let's write that directly. 10 cos cube theta plus 3 cos theta minus 2 into cos theta minus cos cube theta. 3 minus 4 is minus 1. Minus 4, that becomes 4 cos square theta. Okay, so this is 8 cos power 5 theta, then cos cube theta plus 3 cos theta minus 2 into cos theta into minus 1 is minus cos theta, so plus 2 cos theta. Cos theta into 4 cos square theta is 4 cos cube theta minus 2, so minus 8 cos cube theta. Cos cube theta into minus 2 is plus minus 2 cos cube theta, and the last term is cos cube theta into minus 4 cos cube theta, that is minus 4 cos cube theta into minus 2 is plus 8 cos power 5 theta. Right? So scroll down. So let's arrange all the terms now. 8 becomes 16 cos power 5 theta, minus 10 minus 8 minus 2, so minus 20 cos cube theta, 3 and 2, that gives us 5 cos theta. Okay, so now we have got that in the form we desired: a cos theta plus b cos cube theta plus c cos power 5 theta plus d. Now so we can compare all the coefficients, and we get that a is equal to, it's that of cos theta, so 5, b is equal to minus 20, c is equal to 16, d is equal to 0. There is no constant here, it's always dependent on theta. So the final relation we need is a plus b plus c plus d is equal to 5 minus 20 plus 16 plus 1. Now that's all. This is obviously the best way to go about it, but suppose you have got multiple choice questions and in an entrance exam paper or on any paper, and you're just supposed to give the final answer. Okay, and suppose out of those multiple choice questions, how you can get this answer easily is, say you put theta is equal to 0. You have to cleverly put theta, choose a theta, so that you get this desired form. This is for particularly this question. What you do is put theta equal to 0. So cos phi theta is again 0. Cos of 0, that's 1. Now all the cos thetas become 1. So you are left with nothing but a plus b plus c plus d is equal to 1. So that way you can verify your answer if you get something like constant here, and otherwise in a multiple choice question you can use this to get the answer very quickly. Otherwise this is the method. So you just expand it and you should get back the formula. Okay. So let's go to the next question. So if a and b both lie between 0 and 3, and the equation x square plus 4 plus 3 cos times ax plus b equal to 2x, now this equation has at least one solution, then find the value of a plus b. Okay. Now and this kind of question actually has at least one solution. That part is important, that there is at least one solution. And the second is one of the most basic say points of trigonometric function. Say like for cosine, the maximum value is 1. It can never be more than 1. The absolute value always is less than 1. So it lies between minus 1 and 1. So we'll have to use that function, that concept here to solve this question. So since there is at least one solution, hence this can be actually written if there are no solutions, then this cannot be actually written this way. So let's just take 2x to this side. So x square minus 2x. Now I'll write 4 as 1 plus 3. I'm doing nothing but completing the squares. This is called completing the squares method. So I'm just completing the squares here. I see that x square minus 2x plus 1 can be written as x minus 1 whole squared. That is nothing but completing the squares method. Plus 3 times 3 cos ax plus b. Now I take the other part to the left side. Excuse me. Yeah. So equal to minus 3 times 1 plus cos ax plus b. Now we know that this right hand side, this part, this is always positive, right? This is always positive, whereas this side, now let's see, cos of ax plus b, well, this will be always less than 1, sorry, this will always be, yeah, this lies between 1 and minus 1, or in other hands, adding 1 to all the sides, we get 1 plus cos ax plus b lies between 0 and 2. So, now 1 plus x plus cos x plus b lies between 0 and 2, but minus 3 into that would change the signs. I'm sorry, this doesn't make sense actually. Yeah. So this will be this way. I actually changed the limit here 2 to minus 6. So the equality signs, the inequality signs still stay the same. So minus 3 into 1 plus cos x into cos into ax plus b will lie between minus 6 and 0. Now we have a dilemma here. The left hand side is always positive. Positive in the sense it can take the value 0, but apart from that it's always greater than 0. Whereas the right hand side is can take negative values when from minus 6 to 0. The only non-negative value it can take is 0. So obviously there is only one consistency, and that is when both of them becomes equal to 0. Right? So this is greater than 0, this is less than 0. So the only consistency is when both of them are equal to 0. When both of them are equal to 0, what do we get? X minus 1 squared equal to 0, or x is equal to 1. The other is 1 plus cos into x plus b equal to 0, or so ax plus b is cos of ax plus b equal to minus 1, or cos of pi. Right? Okay. So actually this can be written as even more multiples of pi, but we have the condition that a and b are less than equal to 3 and x is equal to 1. So ax plus b, you can see that, you can check that later actually. So ax plus b equal to pi, or since x is equal to a plus b is equal to pi. Hence, we find the value of a plus b. This was actually the reason behind these limits of a and b of being between 0 and 3. Otherwise, you will have multiple answers, because cos of minus 1 can be given by actually 2n pi plus pi. Hence, the key idea here was to complete the squares. It was more of algebra here, and then using the inequality or the restraints on cos of any angle. So let's go to the next question. Okay. So find the values of k for which the system of equations cos x into cos 2y equal to k square minus 4 whole square plus 1 and sin x sin 2y equal to k plus 2 whole. So these are the equations here: cos x cos 2y, sin x sin 2y. Okay. So for this question, okay. So cos x into cos 2y equal to k square minus 4 whole square plus 1. Now we know that cos of any angle, okay, cos theta, so that is, this lies between 1, right? The absolute value lies between 1. And similarly, actually cos of say phi, some other angle, would also lie between 1. Now it's natural that, pretty obvious that cos of theta into cos of phi would also lie between 1, right? But the first expression says this is equal to k square minus 4 whole square plus 1. Now again we have k squared minus 4 whole square, which itself is greater than 0. Now add 1 to it. So so this part actually is greater than or equal to 1, right? but that is not possible. I mean, the maximum value is equal to 1, and here the minimum value is equal to 1. So hence, cos x into cos 2y must be equal to 1. That actually simplifies a lot of things. That means both of them have to be either 1 or minus 1, because plus 1 into 1 is 1, minus 1 into minus 1 is also 1, right? So x is equal to, say, if x is 2n pi, then y will be 2n pi by 2 actually, so n pi, or this is the second solution, x is equal to, say, 2n plus 1 pi, and y is equal to, okay, we should not write n pi here, we can actually use a different one, because that would then restrict our solution set. This can actually take some other values, so m need not depend on n here. So similarly this is, say, 2m plus 1 pi by 2, right? So let's see now. So sin x into sin 2y is equal to k plus 2, right? So let's see what how we can put these equations here. Now sin x into sin 2y. Now sin of, whether sin is, suppose it is 2n pi, so it will be still sin of 2n pi is 0, and so is sin of 2n plus 1 pi, right? So this is always equal to 0 actually, because anyway sin x, cos x and cos 2y equal to 1. This implied that cos x is equal to 1 and so is cos 2y. I mean, it's actually plus or minus. Okay, both of them have to take the plus sign or the minus sign together. So sin of x into sin of 2y will actually be 0. Both of them are actually 0. But this is equal to k plus 2, right? That means k equal to minus 2. Now, here actually from here we got that k squared minus 4, that had to be 0. So k could be plus or minus 2. But from this equation it clarifies the matter, and that is that k, the only value of k can be that k is equal to minus 2. So this is the solution. K. So there is only one solution, that k is equal to minus 2. So this is how again you use the bounds on the trigonometric ratios here, and using them you solve say the unknown constants and find the various values you can take. So thank you for watching this video. In the subsequent videos we will be taking on more trigonometric equations and ratios. Here we just started with them. Basic idea was given here. We will now take on more and more angles, say the solution of triangles and all those things. So stay tuned. Thank you.